Welcome to Building Real-World Serverless Applications with AWS SAM and Capital One. My name is Eric Johnson, and I'll be introducing George Mao in just a few minutes. First, let me tell you a little bit more about who I am. Again, my name is Eric Johnson. What do? I'm a principal developer advocate for serverless at AWS. I've been a developer forever. I've been a solutions architect forever, probably since some of you were even born. I'm pretty old. So I'm a husband of one. I'm a father of 5 amazing kids. I'm a drummer. That used to say musician, but now it just says drummer because that's debatable, of course. And I'm a massive pizza advocate and lover and have lots and lots of Twitter feeds about that. So with that, I'm going to pass it over to George and let him introduce himself.
Hi, everyone. Welcome to reInvent, and I'm glad you've joined me here. My name is George Mao, and I am a Senior Distinguished Engineer with Capital One. My responsibility is to help our developers build serverless applications and to help enable our entire organization, our tech organization, build and use services like Lambda and SNS, SQS, and Kinesis. I'm a software engineer at heart, and before my time at Capital One, I was the head of solutions architecture at AWS for serverless computing, and actually had a lot of opportunity to work with our other speaker, Eric Johnson. So happy to be here, and I hope you are excited for the SAM session.
All right, so let's look at today's agenda. Today we're going to be talking about AWS SAM and how it's used in real world, but we'll give you a quick introduction to SAM if you're not familiar with it. We're going to talk about real world use cases with Capital One, and George is going to talk to you about how they use it. And then we're going to look at AWS SAM Accelerate, which is a beta feature or set of features that is coming out, and then we're going to see it all in action. There'll be several demos kind of sprinkled in throughout here. So let's get started. So today, again, we're talking about the Serverless Application Model, or SAM. And you can see here we got the squirrel. If you watch reInvent this year, you might see me in the same squirrel outfit. So this is Sam the squirrel, who stands for the Serverless Application Model. Now, the Serverless Application Model comes in 2 parts. The first off is the AWS SAM transform. And this is shorthand syntax to express resources and event sources within your application. This is basically infrastructure as code. The second part is the AWS SAM CLI. And this provides tooling for local development, debugging, building, packaging, and actually remote development as well, as we're going to see when we talk about SAM Accelerate. So let's just kind of get an idea of what that looks like. So this is an example of the SAM transform, or the template, or infrastructure as code. And you can see in these 20 lines of code, I'm going to create several things. First of all, I'm going to create an AWS Lambda function. And inside of that Lambda function, I'm also going to create the AWS Identity Access Management role that allows that function to talk to other services. And I'm going to create an Amazon API Gateway as the event source for this application. Finally, I'm creating a DynamoDB table, and I'm allowing that Lambda function to talk to the DynamoDB table. So when I run SAM deploy, it takes these 20 lines of code and it creates this architecture. You can see here where I've got the API gateway, I've got the Lambda function, I've got the DynamoDB table, and wrapped around that is the roles and permissions required to run that. Now, SAM is built on top of AWS CloudFormation. Now, if you're not familiar with AWS CloudFormation, it is the premier infrastructure as code service for all the AWS services, and it uses JSON or YAML templates. And in a sense, SAM is just CloudFormation, but it adds 7 specific serverless resources. And so what happens when you do a deploy, we go back to those 20 lines, and we actually expand those specific serverless resources out into actual CloudFormation resources. And so this particular template is upwards of 188 lines. Now, I don't know about you, but I don't want to type 188 lines. So with these 20 lines, I can create that using SAM. So let's look at some of the resources. Now, this is not a dive deep in SAM, and I'll give you a link to that in just a few moments, but I want to kind of give you an idea of how these resources work. So there are 7 serverless resources types, and you can see them here. We have function, we have 2 types of API, we have a simple table, we have layer version, application, and state machine. And all of them allow you to create these resources in the cloud. So let's look at the function to see kind of how it works. Now again, we go back to these lines of code, and you can see in this, I'm declaring the properties about the function itself. I have some policies that I'm creating. I have events. I'm setting the architecture. In fact, the architecture is new. This is something that we just added this year, in that you are able to choose between x86 64, which is the default, or you can now do ARM 64, which is a percentage cheaper and more performance. So definitely look at that, and that's kind of I would look at using that before x86 if it works for that. So in this, I also said you set the event source. In our first example, I showed you how to do an API gateway as an event source. There are actually 16 event sources that you can use with a Lambda function, and they're listed here. And examples are like Kinesis or DynamoDB, MSK, or an Alexa skill. There's all kinds of different events that you can put right in the template transform, and it'll actually create or tie the events together. Additionally, we talked about policies. And there are actually 75 plus policies built in with SAM using the SAM resource policy templates. And here's how that works. Again, we have 75 plus, and you can pick the template you want, and it'll show you here's the permissions that we're going to apply. In this example, this is a DynamoDB read. So I can get item, I can delete item, I can put item, and I can scan. This is actually a CRUD, DynamoDB CRUD policy. And then it tells you what you need to pass it. So when I build this, so let's go to the example. When I build this, I do a DynamoDB read policy, and then I pass the table name for the product table. And that allows me to say that I can do read only to this table. So it's very limited policies, and it starts with least privilege. And that's our best practice for least privileges. Additionally, this works with functions and state machines. So you can apply these policies to functions or state machines. The last thing I want to kind of highlight here are the build options. When you're building Lambda functions, and this also works with layers, you have the option to do the standard build method, which is applied to any of our supported runtimes. So it'll build with Python or Java, and with Java, I can say, I can use for my dependency manager Maven or Gradle, and I have some flexibility there. But you also have the flexibility to do a custom build, and the custom build allows us to do the makefile as a build method, and then you can create your own method of building. You say, hey, I want you to grab these files, drop here, grab these dependencies, whatever you need to do. We have an example of this, and you can see the link here at s12d.com/custom build, or you can follow that QR code. Now, I obviously didn't cover all the resources. Doing a deep dive into SAM can take hours. In fact, I did this before you, and you can look at s12d.com/sam deep-dive. And in this session, I actually go through every single one of the resources. I talk about the parameters, and I also climb into the CLI, which I mentioned earlier is the second part of SAM. And we're going to see some of that CLI in action today. First of all, towards the end, I'm going to be demoing some of the new SAM Accelerate features. But George is also going to show how they are using SAM CLI inside of Capital One in real world testing and debugging. So with that, I'm actually going to turn it over to George and let him tell you all about Capital One.
All right. So thank you, Eric. So we just heard about SAM and how you can use SAM to build applications and speed up your development cycles. I wanted to tell you a little bit about how we use SAM in the real world, and then jump through a quick demo to show you how your developers can work through really quick development cycles. So just to introduce Capital One, I think many of you probably know who Capital One is, but we are a US-based bank. We started our journey into the cloud in 2013 or 2014, where we decided to be all in on AWS. So we began by migrating our dev and test environments over to AWS, and this was a really great cost savings for us, as well as being able to build and release much quicker. In 2016, we had our dev and test environments in the cloud, and we had learned a lot about how to use AWS. And then in 2017, we started forming our governance journey and making sure we have all the compliance for cost management, security, automation, building all of that maturity into our cloud experience. And then in 2018 and 2019, we built out and prepared all of our environments for production ready use cases. And then finally, just last year in 2020, Capital One closed our last data center. So I'll tell you a little bit more about that. When we closed our data centers, we had 8 data centers operating, and we closed all of them. The last one closed last year. So here's some really cool facts about that journey. So 8 data centers resulted in us recycling over 103 tons of metal, so copper and steel. And we had migrated nearly 2,000 applications over from those data centers into the cloud. And one of the best benefits of this is that we can now create development environments in just minutes, versus multiple months when we were on premise. We had to provision hardware and sometimes procure that hardware. Now we can just go in AWS, deploy a few templates, and we're good to go. Another great fact is, other than Netflix, we are currently the only Fortune 150 company to accomplish an all-in effort of this scale. And then a cool side note is that because of these data centers we're no longer operating, this is a really nice thing for our environment. Imagine the cooling and electricity that we no longer have to operate and pay for. So let's jump into a demo. I want to show you how Capital One uses SAM and how it improves our development cycles and helps our developers be a lot more productive. I wanted to give you an overview and a demo of how Capital One uses SAM and give you an idea of how flexible and powerful SAM is running right there locally on your machine. So as Eric showed you, everything in SAM begins with a template.yaml file. And this file defines how to build your serverless application. You'll notice here on line 2, you'll see a transform directive. And that transform directive says AWS serverless. And if you see this, this means it's a SAM template. And CloudFormation will take this template and then transform it from a CloudFormation template into a deployable CloudFormation template, and then deploy that on your behalf. So let's look through this template here. I've already written this template, and in the resources block, starting on line 11, we are creating a simple function. It's just called products function. And I can tell it's a Lambda function because the type of resource is type AWS serverless function. And my goal here is to simply create a REST API that serves up a list of products. So there's a couple different properties that I'm defining here. As you can see, I'm specifying that my code lives in a folder called source. The handler, or the entry point of my application, is app.handler. So that's a file name called app. And then it's a function called Lambda handler. Line 17 is where I define the runtime. I am using Node.js 14, but I could have used any one of the other runtimes supported by Lambda. I'm saying this function is going to need 256 megs of memory. I can specify anything from 128 all the way up to 10 gigabytes. And then under the events section is where you specify the different events that will trigger your Lambda function. So in this case, I'm specifying a API. So this is a REST API that will be invoking my function, and I'm providing a bunch of properties. So this is going to be hosted on the path/list, and I could call this whatever I want. Right? I could call this /hello/list/ update, whatever it is I need, and then I just specify the method. So I want /list to respond on the get method. So Capital One, we are building a lot of REST services, and a lot of our applications do communicate with Lambda functions on the back end. So for developers, they can build the stuff locally. It's a massive productivity gain. So we'll take a look at our app here. So app.js. We can see on line 4 is my Lambda handler method, and this is the entry point of my application. It's pretty simple right now. All it's doing is generating a response, setting the response status code, making sure it's not base64 encoded, because this is just going to be a REST API. If I were building a different type of API, I might want this to be base64 encoded, and I'm setting up some headers, and then I just return the response. So in order to run this, it's pretty straightforward. So down here in my terminal, I do sam local invoke, and then I'm passing it through a little JSON editor called JQ to make it readable. And then I hit enter there. And as we can see, this is the my Lambda function executed locally on my machine. It has all of the Lambda reporting, the start, end, and the report line. I can see my function took 261 milliseconds to run, and it used 256 megs of memory. And then this is the response code, right? I generated this stuff locally. So now, if I wanted to test my application as a REST API, I can do sam local start -API. And what this will do is deploy a local REST API right on my machine. And as we can see here, it mounted my service at localhost, port 3000, and then it's going to say deploy on the /list call. So if I click on this here, this will, I can see that I have executed this application, but it says Lambda returned empty body. So that doesn't sound good. You know, I definitely am trying to return a list of JSON payloads. So what I want to do is take a look at my application and try to figure out why. So if I go here, in my application, I can see that my response body is just commented out. So I accidentally left this commented out when I was playing with development. So what's really powerful about SAM is I can make changes on the fly and hit save and then hot swap. So once I do that, I can reload this call here. I just click on that. And as we can see here, it is no longer saying Lambda returned empty body. So now we can see that after the start line, I have an info line where it's returning a single JSON payload with the ID of 0, description is kitty, and price is 8. So if I want to step out of this, I just hit Control C, and this will close the REST API. But what I wanted to show you, which makes SAM really powerful, is in most scenarios, you're probably working in a larger dev team where you might have a bunch of developers working together and sharing common code. So for example, if Eric wanted to provide me with a SDK that allowed me to read secrets from our secrets library, I could take his code that he gives me, and I could simply go to my package.json file and then copy and paste this in from my dependencies and place it in my dependency list, right? And then do a simple npm install, and this would bring down all of the new dependencies into my Lambda function. So there's a couple caveats to doing this. You know, if you have many different Lambda functions, each function will then pull down the dependencies themselves, right? In most cases, you know, at Capital One, we're building tens and hundreds of Lambda functions, and you might end up deploying common code across all of them. And then maintenance becomes pretty difficult because you have to, if Eric were to update the, in this case, secret sauce node library, I'd have to go and update this in every single Lambda function. So in order to avoid that, I won't place this here. Instead, I will use something called a Lambda layer. And a layer is just a configuration item, but you would deploy the dependencies to a layer. So in this case, I have a layer set up. The layer will have the dependency in it. And what I will do is reconfigure my SAM template to use the layer. So in order to do that, I will just copy some code that I've already written here. And this is the code that I have for adding a layer. And I'll show you exactly how to do this. So in order to add a layer, it's a simple one-line item here that we will deploy. And this is a simple attribute called layers. It's going to reference a layer called myLayer, and I will define the layer using the snippet of code here, and we'll walk through this in just a second. So, so here I can see that I'm creating a layer called myLayer. It is pointing at source code that sits in this directory, and this layer is compatible with the node runtimes, specifically node 12 and 14. So once I have that set up, I now can use this layer from my Lambda function. And if I were to make a change to this source code in this layer, I only have to change it in one place. And this layer will then get redeployed to all of the Lambda functions that are using my layer at configuration time. So that's super important. And in an enterprise as large as Capital One, we want this to occur because we don't want to have to update potentially hundreds of Lambda functions when a single change has happened, right? So I'm going to copy the rest of our sample code here and just drop it into our application. And then from here on out, we should be able to use the code in our layer. And there's a function called read secrets that we're going to invoke here. So on the bottom, in the terminal, I'll do sam local invoke, pass it through JQ so we can make JSON readable. And as we can see, it's building the image, and Sam will execute everything locally. And then, as we can see here, now my application is able to load secrets, and I have loaded secrets from my secret store. And in this case, I'm emulating the secrets locally, but my application is set up to pull from a actual data store. And then, so pretty straightforward. If I were to update that layer, everything would upload to my Lambda function. And as you can see, everything is working locally. So I haven't deployed anything to AWS, which means my development cycles are much faster than if I were deploying to AWS. And then the final thing I want to show you is most developers, if you do have a bug, you want to be able to debug locally and trace and look at all of your variables and how your code is executing. So in order to do that, Sam gives us a debug option. So I've just put a breakpoint on line 51. I also put a breakpoint on 56. And on the bottom here, I'll do sam local invoke. And what this will do is invoke my Lambda function, but I need to provide a -d option for debug, and I'll provide port 8088. So this basically will stand up a debugger on port 8088, and then I'll bring up the debugger console, attach it to my function, and from here on out, I should be able to debug like normal. So as we can see here, my debugger has now dropped into my application on line 51, and I can step through each line as needed, and I can inspect my variables just by hovering over them, just like I would expect for traditional development locally, and then continue to step over until I find the line of code that is causing me a problem. But in this case, my code is working properly, and then it's just going to complete and return the response. So definitely encourage you to check out SAM. One of the best features about that is the debugger, be able to test your functions without deploying anything to AWS. Last thing I want to show you is there is a SAM helper. So if you just do SAM on your console, you can do SAM local and then just hit enter. It'll give you a bunch of commands that you can use, but one of the most useful ones is called generate event. And you can use this to see what all types of AWS events look like. So SAM local generate dash event. And from here, you can see all of the supported event sources. So for example, if I wanted to see what an S3 event looked like, SAM local generate event S3, I would specify either a put or a delete. And if I specify a put, this is what a S3 event looks like. And I can use this to code up my application. So hopefully you found that useful, and hopefully you'll be able to deploy SAM into your applications and help your developers improve their productivity. All right, so we just saw how Capital One and most of our developers use SAM, and I hope you can be able to take away some of the learnings and try these services in your own development environments. I'm going to turn it back over to Eric, who's going to cover a really cool feature that's coming called SAM Accelerate.
All right. Thank you, George. It's exciting to see how SAM is being used in the real world. Enterprise companies are using it every day to speed up development process, to go to market faster. One of the things we've heard from developers is, as much as they love SAM and they love serverless, testing can be complex sometimes. And while testing locally is great, sometimes we wrestle with emulators, or we have the option where we have to redeploy the stack every time we want to test it in the cloud. So we've been listening. The SAM team has been listening really close, and so we came out with SAM Accelerate. Now, SAM Accelerate aims to increase infrastructure accuracy for testing with incremental builds, SAM sync, and aggregated feedback for developers. Now, if you don't know what that means, let me explain it. First of all, let's talk about this infrastructure accuracy. The reality of testing is, with serverless, a lot of times we find ourselves emulating the cloud locally. We grab some of these emulators, we're trying to connect them with Docker Network, we're trying to get that all working, and it can be complex and kind of frustrating sometimes. And sometimes you wonder, if I'm getting a bug, is it the emulator? Is it my code? And sometimes you never know. So we believe for the best infrastructure accuracy is test in the cloud as early and soon as possible. Now, sometimes you want to do quick iterations with your API gateway and Lambda, which you can do with SAM Local. SAM Local is provided by the AWS team, and it is the closest to emulating API gateway. But it's not a full implementation of API gateway, nor is it a full implementation of Lambda functions. So when you're testing locally, it's really just for quick functional tests, right, to make sure those are working. But after that, we really encourage you get to the cloud as soon as possible. And that's what SAM Accelerate helps you to do. The first way we do this is through something we call incremental builds. Now, currently, when you do a build, it downloads dependencies each time, it builds the code, puts it all together, and you can run SAM Local to invoke that. But what we're doing is we're changing this to say we'll only build the requirements text, or your dependency, depends on package.json or whatever you're using for your runtime. We'll only build the dependencies if the dependencies change, meaning we cache the code and the dependencies separately. I just make up words as I go here. And that way, when we detect a change in the code, we build the code. When we detect a change in the dependencies, we build the dependencies. And so they're done separately, and it makes build much faster. The second thing we do is we're using SAM Sync to upload or sync your code in the cloud. Now, to understand how this works best, you got to know what we consider code, right? The first thing is AWS Lambda function code. Obviously, it's the code in your Lambda functions that we consider code. The second is AWS Lambda layer code. So if you're creating a layer and you're working with a layer inside of your template, that will be considered code. Excuse me. The third is step functions Amazon states language. Now this has to be a file outside, so you have SAM template in the definition URL. You can refer to the template, and as that template changes, we'll push changes to the state machine, the step function for you. And finally, API Gateway Open API. If you manage your API gateway with an Open API template, which is recommended, it works really well, then that's identified through the definition URL parameter as well, so it's an external file. Then when you make changes to that, we'll sync that with your API gateway. So all those things are considered code. Everything else is configuration, right? So if you change the memory for a Lambda function or something like that, that's considered configuration, and that requires a stack update. So let's look at some examples. So again, like I said, currently, any changes you make require a full stack update. But with this change, let's say I make a code update to my Lambda function. With that change, only the code for the Lambda function will be updated. And one of the things we do, which is really cool, is we also take your dependencies for that and we separate them into a temporary layer for debugging. So we'll push layer changes as well when you change the dependencies, when and only when you change dependencies. So again, it makes for a much faster sync. We're trying to make this as fast as possible. Let's say you make an ASL update. This is the Amazon States language. Only that would get pushed up, right? So we wouldn't have to do a full stack update. We would just push the ASL update. Let's say you make a change to EventBridge configuration. Well, that's configuration, so we need to do a stack update. However, using the, CloudFormation already knows only update what's changed. So it'll only update that particular change, but that does take a little longer. And finally, if you have an Open API gateway, Open API template, and you make the change in that template, then just that change will be made. Let's say you make a Lambda function configuration, like I talked about earlier. You save the memory, you save the storage, things like that. Then we're going to need to do a stack update. And our last example is a layer update, where if you do just the layer changes, it'll push just the layer changes up for you. So this is if you're managing your own layer as well, and this won't be a temporary layer, it'll be an actual layer. But the nice thing is if you change that, it also updates the reference in the Lambda function to point to that. All right, so this comes with AWS SAMsync when we're doing that, and also SAMsync watch, which it's part of the watch is just a flag on the SAMsync command, and I'll show you how that works in just a little bit in our demo, and it's really cool. I'll be anxious to show it to you. The last thing we're doing this is the aggregated feedback for developers. And this is through a command called samlogs. Now, samlogs has been around for a while, but it has only grabbed logs for a specific Lambda function. What we're doing to change this is we're actually going to say, when you do samlogs, you could just do samlogs on the stack, and we'll aggregate all the logs throughout the stack. So that's going to be API gateway logs. It's going to be step function logs. It's going to be Lambda function logs. Also, we're adding X-ray traces. So we grab the logs from CloudWatch and we grab the logs for the traces from X-ray to give you a full picture of what's going on. And that'll come down in your terminal. So literally, and I'll show it in the demo, just a simple command like samlogs, you pass the stack name, and it's going to aggregate all that information down. So when you're debugging, you have the information available at your fingertips. Now, showing you in a slideshow, that's great. You're like, Eric, show me some code. So with that, we're going to see it in action. In the first part of this demonstration, I'm going to go ahead and create a new application and demonstrate how the new incremental builds, a part of SAM Accelerate, helps you to do faster builds locally. So let's go ahead and create a new application. I use SAM init to do this. I'm going to choose one for Quick Start templates. I'm going to choose one for Zip, and I'm going to choose two for Python 3.9. I name the app RI Simple, and then I clone the templates and choose one for Hello World. I'm going to change into that directory, and you can see here, I'm in there, and I'm going to run SAM build using the -- cache and the -- beta features, and it'll do its build. So let's see what it does. Okay, and you can see here that I've got the manifest is changed. So it knows, hey, there's no cache for this, so I'm going to go ahead and build out everything you need. And it built both the dependencies and the code. I'm going to run it again, and now it says, nope, nothing changed. So that was a quick build because we're just using the same cache. So it did a detection on that. So real quick, let's go ahead and test this locally just to kind of see what that looks like. So I do SAM local invoke. And you can see here, I get my status code, message, hello world. This is everything out of the Lambda function. Let's go ahead and change the code just a bit. So we're going to try my vimfoo here. And I'm going to be really honest, I'm not really good at it, so I'll let you suffer through. Let's go ahead and change out. We're going to uncomment a little bit of the code that actually does a call to find out what IP this is being called from. So, and this is part of the standard template if you do the SAM init, so you can kind of see how this works in using libraries. So I go ahead and finish uncommenting these. And I know if you're watching, this is probably painful, especially if you're good at Vim. You're like, oh my gosh, there's got to be a better way to do this, but here we go. All right, so everything's updated. I'm going to go ahead and save that. Now I'm going to build this again by doing SAM build cache beta features. Now notice that the manifest has not changed, so that's the dependencies. So we're going to do an incremental build, meaning I'm just going to build the code itself. So it was very quick. Let's go ahead and run that using the SAM local invoke. And you can see, boom, we got our information back, including the location and the IP address. So it did change how that works. Now let's show what happens if we actually do change the dependencies. Back to Vim, trusty Vim, and I'm going to actually change the requirements text. So let's go ahead and do this. Okay, and as usual, I have misspelled it, so let's go back, change that. I've always said I'd be a better developer if I could spell. So I'm gonna add, now I'm not actually using Boto 3, but I'm gonna actually add it in so that it thinks that I'm going to. So let's add that, we'll save it, and then we're gonna do the build and watch what happens. And there you go. It said the manifest has changed. So we're going to go ahead and change up or rebuild the dependencies. And that makes it where everything we need is downloads the dependencies, installs them, gets it all in place. In the next part of this demo, we're going to show the SAM sync and SAM logs and how those work and SAM traces, and maybe a surprise. So first of all, I'm going to go ahead and start SAM sync because the first thing it's going to do is actually sync all the infrastructure. So I'm going to get that started so we can talk about it. I need to go ahead and tell us, yes, I'm good with beta. And it is syncing the local infrastructure with the actual infrastructure in the cloud. So let's look at the new stack we're going to use. This is a little more advanced than the one we used before. I have some global setting tracing for APIs and the functions. And then I've got my actual API. Now this time I'm declaring my API separately from the Lambda function, and I'm using it through the definition URI through a file called api.yaml. And I do this because that's what SAM sync will update. And you can see in this file, I've just got a simple, all I'm doing is calling that function itself and getting a return. So the next thing is if we go in here here's my hello world function, just a simple function that's actually the one we just showed. And then I'm also doing a state machine, and I'm declaring it also through the definition URI here on a state.asl.json. And if you look at that, it's a very simple, the simplest you could do, just return anything I passed in. So we can kind of look at that. We'll make that a little more complex in a little bit. Finally, the last thing I've got is a Hello World API role, and this is the role that allows that API to invoke both the Lambda function and the state machine. So I've got everything I need in the template. So let's go ahead and take a look. And you can see my sync is done. Everything's come down. So we're going to grab the API endpoint and let's go ahead and test that to kind of see what happens. So we're going to pop over to a terminal. And before we test that, I want to start the SAM log so you can see what we get. So I'm doing logs, the stack name, and I'm tailing it. And you can see I already get some data back because of course I was testing this before I'm videoing it, before I'm showing it. So now let's go ahead and curl that endpoint and see what happens. Well, you can see I instantly get this back. It's right out where we left off earlier from the earlier demo, and I got the location. And down here, we got logs back. So, and this is a polling, so sometimes it can take 1 or 2 seconds, sometimes it's instant, depending on where it is. But let's go ahead, and what we're going to do is we're going to change this. I want you to see the difference in how fast this syncs up. So I'm adding a log, and I'm going to change this to say, hello world, how are you? ? And then what's going to happen, if you watch below, I'm going to scroll this up so you can see it. If you watch below, I'm going to hit save, and it'll start off, and immediately it's syncing the Lambda function, and it's done. So it's that quick. The Lambda code is already up in the cloud. We can go ahead and curl that again and see what happens. And you can see my code is updated. So now it says, how are you? And let's go down and look in the logs. Yeah, there it is. We have the hello logging. You can see it right here. And so now I have the logs coming back from SAM logs, collecting up that data. Excuse me. All right, so let's go ahead. Now, if you remember earlier, oh yeah, I want to point out here that we do have the HTTP logs as well. So you can see, and I'm dumping all my logs in there, and these are the actual execution logs that we're getting. So if you remember in the earlier, I did add Boto. We don't really need Boto, so let's remove that. And I want to show you what happens. So watch down below, and we have this thing happening. We're syncing the dependencies, but the dependencies are being synced as a temporary layer. We have this layer we've created for you called the hello function, some numbers and layer, and that's finished syncing. And so now I have a new layer, but it also updates the Lambda function to point at the latest layer. So it's a temporary layer we create, we update the function, and there you go. So Next thing we're going to do is we're going to update the API itself. And I'm not going to pretend to type it all in because nobody wants to see me prove I can code. But we're going to copy a little more complex application. So we're going to copy this and drop it in. And this actually adds a second endpoint that calls the state machine like I was talking about. So you have the first one for Lambda, the second one, state, that'll call that. Now, when I save this, watch what happens below. It syncs the open API and it updates the template, or it updates the infrastructure. Now I'm going to curl that and I'm going to add, of course, the state endpoint. And you can see I get a response from the state machine. That wasn't even there a few seconds ago. And now it's there. Now it's just basic information because the state machine isn't doing anything. So it's just kicking out the metadata, right? But if I look down here, we'll wait on it. There it is. If I look down here in the logs, I now have the API logs showing that I hit the state resource path. So let's make that a little more fun. So what we'll do is in our state machine is we're going to get rid of this simple one and we'll grab another one. And this actually invokes that same Lambda function we've been using. So I'm going to grab that. I'm going to paste it here. I'm going to save it and then watch what happens when I save it. You can see again, it's a lot more complex and save. There we go. And it's syncing step functions hello world. That delay is me hitting save, not it immediately syncs. So if we go over here and we call that state machine again, you'll notice now we're getting that body information back, that hello world and the IP and everything we need. So it was an instant change. And you could see how this will make developing much faster because you instantly get these responses. Make a change, it's synced, and there you go. All right, so, and of course, we look down here and we are getting all the information out of our logs, and there you go. All right, so the next thing we're going to do is I want to change the logs, and this time I'm going to add include trails, or tracing, I'm sorry. I could spell tracing, trails, traces, traces. There it is, include traces. So again, this is beta, so I got to tell it yes. So I'm going to go ahead and you'll see here, I now have tracing information. I turned on tracing, if you remember earlier, I turned on tracing in the stack, and now I'm getting information about the state machine, the Lambda function, the Lambda service, step function service, all the information to see what kind of latency I might be seeing and how I can make that work. Now I'm going to stop this, and what if I just want tracing? Now, first of all, if you want to look at the CLI help, you got to spell it right. But you can see in here, there's a command that says traces. So I'm going to go ahead and try that. So I'm just going to do clear the screen, SAM traces. But notice I'm inside the folder, so it's reading the template to know where that's coming from. And there's just the traces. You can see here, there's the prod endpoint, there's the Lambda function, and then right up here, we have the Lambda invoke service, and we have step functions. So the traces gives you an idea of how that works. Super helpful. Hope that helps. Let's move on to the next part. In this last part of the demonstration, I'm going to show you how to create a CI/CD pipeline, or continuous integration, continuous delivery pipeline, to deploy this application you've been working so hard to build. We have a new feature called SAM Pipelines, and SAM Pipelines creates all the resources and the integration with CodePipeline or third parties like GitHub, GitLab, or Jenkins. So let's get started. The first command I'm going to do is SAM Pipelines Bootstrap. Now, like I said, this creates all the resources that you need, the permissions and everything for one or more accounts, depending on how many stages are going to be in your pipeline. So the first stage I'm going to run is beta. Okay, so I'm building my beta environment, and I'm choosing I have a demo account that I use. So it actually ties it to that demo account. I choose my region, and then I'm going to I can create my IAM user if I want to, but I'm going to let this create it for me. So we're going to walk through, and I just tell it, yeah, you create everything I need. Once that's there, then it says, do I have any images? Am I using containers? And this one I'm not, but it does work with container images. So it gives me a summary. Hey, it's going to be in this account. Here's the configuration. If you're ready, go ahead and hit it. And it creates it all. And I've sped that up a little bit because it does take a little bit to create the resources. Now you'll see it kicked out some access keys for me here. I have the access key ID and I have the secret key ID. And yes, these will be deleted. You're welcome to copy these, but they will not work. But those are important for the authentication, depending on which pipeline I'm going to use. Now you can see I have the instructions here, and it'll tell you, hey, how do you set these up? And we can go look at that. So we'll go pop over here, and you can see the instructions. It's laid out for the different for whichever you're going to use: Jenkins, GitLab, GitHub, excuse me, or Code Pipeline. For me, in this example, I'm going to use GitHub. So these are the GitHub actions, and it shows me how to set up my security credentials. So I'm going to show you how to do that. So if we go over to the actual repo, I'm going to go into settings, and I'm going to go down over on the left side, and you see a tab called secrets. And in these secrets, I'm going to add a new repository secrets. Now, I like to use the same name that they recommend because it just makes it easier later. So I'm going to call it AWS Access Key ID, paste it here, and then I have to grab the value itself. So let's copy this, my copy paste foo here, copy pasta. All right, so paste that. So we add that. So we're going to add one more. That's just the key ID. We need the secret or the access key as well. So let's grab that. We're going to keep it the same name. And we're going to post it in the name here. Excuse me. And then we're also going to take the value and we're going to post it in the value. So what this does is this gives the information, stores it in secrets in GitHub that I can use to access my AWS accounts to do deploys. All right, so now that that's in place, I need to run SAM Bootstrap again. And you say, well, you've just done that. Why again? I need to run one for each environment I plan to have so I can set it up. So this is going to be my prod environment. And I have an admin account that I'm going to run that in. So I'll tie it there. And this is associated. I'm going to the same region. Again, I'm going to let it create everything I need. Now, here's interesting. It's not going to kick out credentials because we've already done it once. Right? So let's go ahead and we'll verify the summary here. And then we're going to enter to confirm. And then we want it to go ahead and build it. I did speed this up again, so it's a little quicker. And notice there's no credentials. It's actually going to use the first credentials and tie the two accounts together, right? So the first credentials will have access to do it on the second one. So now we do SAM pipeline init. And this is where we connect all these resources to okay, spelling as always. I've always said I'd be 10 times a developer if I could spell. This actually connects the whatever code pipeline or something like that we're going to use to the resources. Now in this one, I'm going to choose GitHub Actions. Now this is a two-stage. This is a pre-built template. It's a two-stage, so it deploys to two different places based on testing, things like that. Now it asks me the access key ID name. What am I calling it? Like I said, I kept the defaults. Same with the secret access key, I kept the defaults. What branch do I want to fire this off of? And then what template file, template.yaml. And then I tie the first one to my beta. So I'm saying, hey, the first stage should go to beta. I don't want to go to prod, then beta. And so what do we call that when we deploy it? We call it RI beta. The second stage should go to prod. And we'll choose that. What do we call it? We call it RI prod. And so what it does now is it creates the information, and it should give me a summary. There you go. So I get a .github folder with workflows, and I have a pipeline all set up to work against that. So how do I make this work? Well, I go ahead, I check. You can see these are new files. So let's go ahead and commit these. So we're going to say I need to add them to stage. Obviously, I need to stage them up here. And I'm going to say git commit. And then let's see here. I always wrestle with what messages I want to do. So we'll go ahead and put add action. No, here we go. Add CI/CD. This slows me down in all my development. I added CI/CD action. So I go ahead and push this, right? So I'm going to push it up to GitHub. And there we go. It's pushed. This is a private repo, so you won't be able to see it, but I'll show you what it looks like. So if we go into actions, you can see under the add CI/CD action, we go in here, it's queued, it's running now. So I show it, and you can see it's in test. Now I have no test, so it's going to pass the test right now. But what would be nice about this is if my tests pass, it's not going to deploy these. So that's how you build a CI/CD pipeline using SAM pipelines. And again, this works for many different properties like the code pipeline, as well as our third parties. I hope this has been helpful. I hope you figured out how to use SAM Accelerate to develop, how to deploy your applications with the CI/CD pipeline. Thanks a lot. Have a great day. So we've done a lot of work with SAM to make it better for developers. And I hope that demo showed you, exactly how much coolness is out there. But we want your feedback. We want to know how can we do better. And with that, we've got an open roadmap. I encourage you to either follow this QR code or the link, SAM-CLI-roadmap, and give us feedback, see what we're working on, see how you can help. SAM is an open source project, and we love your feedback and we love help. The other thing is, if you want to climb more into SAM Accelerate, I encourage you to check out the s12d.com/accelerator, follow the QR code. There's only so much we can cover in a small amount of time with the demo and things. So a lot more information here, how to get started, how to start using it locally immediately. So I encourage you to do that. Here's some other resources. We have a website that we maintain, my team maintains, called serverlesslane.com. And this has all kinds of information, links to videos. It's an aggregation of videos, blogs, learning paths, all kinds of things. We also have a website or a YouTube channel called youtube.com/serverlessland. A lot of the videos on serverlessland.com point here, so it's an aggregation of those, but all kinds of series on how to learn serverless. And finally, every Tuesday at 10 a.m. Pacific time, we have serverless office hours. It's on twitch.tv/AWS live. We also stream live to YouTube, and you can get the link on the YouTube channel. With that, for George and I, George, I really appreciate you being here. Thanks so much for joining and chatting with me and talking about how Capital One is using SAM. I thank you. Follow us at George Mao on Twitter or EDJ Geek. I talk a lot about serverless. I also talk a lot about pizza, Diet Dr. Pepper, those kinds of things. So, prepare yourself, good with the bad, right? Again, I want to say thank you, and I encourage you to fill out the survey and tell us how we did.